Hello, hello. Let's do some maths. Some mathematics. I don't know whether I should play some more upbeat music to get myself excited and pumped up. I felt like kind of in a calm mood. And this is the only kind of non-copyright playlist I have, so I'm just going to have to kind of stick with it, I guess. But I do feel like I need something like, you know, fast-paced, but none of this is. Oh well. Yep. Summer is over, guys. Sad times. In this video, I'm going to be going through this exam paper here. Now this is going to be a bit different to what I usually do, because I haven't looked at this paper yet. Usually I look through a paper, well, to be honest, when I sit down to do an exam paper, I will try to be really prepared. So I'll sit down and do the paper as though I was actually doing the exam. And I'll try to have all the formulas and everything in my head ready to go as though I was actually doing the exam. But for this one, I haven't looked at it, I'm not feeling prepared, and I wouldn't recommend doing this yourself, but sometimes it's better to do something badly than to not do it at all. And it's kind of a bit about motivation for me, so yeah, we'll see how we go. Hopefully it's not too terrible. Alrighty, let's get started. Now this first question I've already done actually. So what I'm going to do is start on question 2. If you want to see the solution to this question, see my previous video on increasing and decreasing functions, where I go through this question in detail. So it's to do with finding the derivative and then finding the range of values for x which y is decreasing, and you do that by finding where the derivative is less than 0. Okay, so we're going to start on question 2. If anyone is there, can I get a sound check? Can anybody hear me? Or else I'll just have to check it myself. Oh, thank you, Nicholas. Appreciate that. Sometimes it's hard when you are, you know, a small creator or whatever, and you don't have a lot of people watching. It's hard to know if, you know, everything's working correctly, so you kind of have to check for yourself. But I appreciate that for letting me know. Okay. Let's try to switch our brains on. Let's try to increase our brain capacities, because we all know bigger is better, right? Using the substitution u equals root x or otherwise, solve 6x plus 7 root x, take 20 equals 0. Okay, well this is just basically quadratic, right? This should be fine. This should be easy. So, well, let's use this substitution. Let's say this is, instead of 6x, let's say it's 6u squared. and see how we go. So can we factorize this? Factors of 20. Factors of 20. 1 and 20. I guess we also need factors of 6. Okay, so factors of 6. 1, 2, 3, 6. Factors of 20. 1, 2, 4, 5, 10, 20. We need to make 7. Seven. 7, 7, 7. 8 and no. How can we make 7? So let's say we used 2 and 3. No, that's not going to work. What about 2 and 3 and 4 and 5? Does that do anything? 8 and 8? No, not really. 1 and 6. 6 and 6 and 13. We can't make a 13. 20 and 13. Well, it's no 13, so what numbers can we make? 6 and yeah, it's not. Is anything working out here? Can we factorize this quadratic? I'm off to a slow start. Channel going to end? No, just summer. Summer is over. It's beautiful weather. It's disappearing. Okay, I'm trying to get my brain switched on. It's not working at the moment. Just trying to warm up. Can I factorize this quadratic? Factors of 20 and 6. I feel like there must be a way. Um, 15 and 8. Okay, yeah, 15 and 8 should work, right? Yes. Okay. I finally saw it. Took me a while. So we're going to use 2 and 3 and 4 and 5. Right? Should work. So if we multiply 3 by 5, so we could have, for example, 3u and 2u, and then 5, positive 15 take negative 8. Right, 15 take 8, 7, yeah. Okay. And now what do we have to do? We're looking to solve this equation. So we want some solutions for u. So u is going to be 4 on 3, or u is going to equal negative 5 on 2. Oh, that might be an issue, right? If we're looking for solutions to root x, well, it doesn't say. So therefore we would have root x equal to 4 on 3, or root x equal to negative 5 on 2. Well, the thing is, this is an AS level pure mathematics paper, so we're not going to be talking about complex numbers here, right? I think we don't have to, it doesn't say only real numbers, but I think we don't have to worry about that. So we're going to say, even though it should though, it should specify if x is a real, or I don't know, what, solutions from, I guess, yeah, I don't know. I mean, I guess they don't have to specify that in an AS pure mathematics paper, but I feel like, I mean, this does have a solution, and it says solve, but anyways, let's just say we can ignore this. So therefore x equals, if we square both sides, x equals 16 on 9. That's a final answer for 2. Alright. Let's just move on. Let's forget that complex numbers exist. There's no such thing as a number equal to the square root of negative 1. Doesn't exist. It's imaginary. Question 3. Looks like we're going to have some bearings here. Figure 1 is a sketch showing the position of 3 phone masts, A, B, and C. Phone masts, like those things that you get reception from your phone with, right? The masts are identical and the bases are assumed to lie in the same horizontal plane. From mast C, mast A is 8.2 kilometers away and a bearing of 72 degrees. Mast B is 15.6 kilometers away and a bearing of 39 degrees from C. Find the distance between mast A and B. Give your answer in kilometers to one decimal place. Let's draw a triangle. Let's try to draw a triangle. Did you like that one? Try and fail. Yep. Okay, whatever. B is 15.6 kilometers away from C. A is 8.2 kilometers away. Okay, so it looks like we're probably using the cosine rule. Right. Oh, you know what I was meant to do? I was meant to pin a comment in the chat. How do I do that? I wanted to I wanted to put the link to the Discord in case anyone had any questions they wanted to post there. Let me just figure out how to do that. Invite people. Copy Hopefully this works. There we go. That should be good now. You know, when summer ends, I get sad. I get really sad. I really like summer. I like the warm weather. And then when it starts to get cold and rainy and cloudy, it's not great, you know. But hey, that's why we're here now, to get motivated, to get some work done, to get our brains focused again. Alright, so there. If anyone has any questions, then that Discord link is where you can go, and you can post anything there that we can have a go at. But for now, we're working through this. Okay, so we have all this information. We have the bearings. A is 72 degrees from C. So remember, bearing is measured from north. So that would be, yeah, that would be this angle, right? That angle in there, and this angle in here is 39 degrees, and this whole angle is 72 degrees. This exam paper is an AS level exam paper, so I'm working through that. So far I've done one question, question 2, and I'm on to, I skipped question 1 because I did that in my last video on increasing and decreasing functions. So we're up to question 3, which is clearly on bearings. Alright, so I'm looking at part A, finding the distance between A and B, giving your answer in kilometers. Well, we have this angle in here, right? The difference between 72 and 39, which is 33. So I have an angle between two sides, and that means I can use the cosine rule. Right? So the cosine rule says a squared equals b squared plus c squared, take 2bc cosine a. Yeah. So b and c being the sides adjacent to the angle, and the angle being the angle opposite the missing side. So pretty much this is a perfect setup for the cosine rule. Because we have all the information, we just need to plug it in to get a squared. So it looks like this question is just pretty much asking you to remember the cosine rule. Is that in the booklet? I always forget if that is in the booklet or not. No, it's something you just are expected to memorize. So, testing your memory of the cosine rule. So let's go ahead and write that down here. I know I wrote it already, but I'm just trying to show you how you could set it out in an exam. So first write your formula down, and then plug in the values. So B was 15.6, or it could be either one. It really doesn't matter what values you give to them, because it's symmetric for B and C. You're in O1. What does O1 mean? O1. 01. Nope, should I know what that means? I apologize. Ah, O levels. Oh, so you're international? You're an international student? Oh, you're doing international A levels? I think, right? Isn't that what that means if it says O levels? 33. Okay, so yeah, that angle is 33. By the way, would you prefer me to check every answer after each question, or check all of the solutions right at the end? So go through the whole paper checking all the answers, or just after each individual question should I check the solutions? Okay, so let's plug this into a calculator then, I suppose. 15.6, or let's make sure it's on degrees because the question is in degrees. 15.6 squared plus 8.2 squared, take 2 times 15.6 times 8.2 times cosine of 33. 96.034 says give your answer to one decimal place, so 96.0, I guess. 96.0 kilometers, and we should use an approximation symbol because we rounded that off. Remember, if it says to one decimal place, always write the 0.0. After every question, alright, okay, so we'll have to go back to the previous question as well to check that. But let's finish this one off first, then we'll check those two. Okay, B. An engineer needs to travel from mast A to mast B. Give a reason why the answer to part A is unlikely to be an accurate value for the distance the engineer travels. Okay, a contextual question. We need to think, why in real life would our perfect mathematical answer not be completely realistic? If we're looking at a bird's eye view of telephone poles, well, is it usually possible in real life to travel in a perfectly straight line between 2 points? Almost never. You know, there's often buildings in the way, there is traffic or roads you have to follow. By the way, this can't be right, can it? I've done something wrong here. Oh, this is squared. Ooh. Don't make this mistake, guys. This is why you should always check your how realistic your solution is before you start rambling on about something else. Because this is a squared, so we need to take the square root. Of course. Hopefully you picked up on that. Oh no, I wanted that answer. Can I still get the answer, I wonder? Hopefully. Yes, I can still get the answer. 9.7997. So this will round up to 9.8. 9.8 kilometers. The square gets me every time. Yes, exactly. Okay. And it's even, it is hard, but obviously I just almost did it myself, but you need to check, remember to check that context, you know. If these distances are 8.2 and 15.6, this can never be 96. So there's often easy checks you can do to make sure your answer is sensible. Okay, 9.8. And then we were talking about B, the fact that it's often impossible to travel directly in a straight line between 2 points. And yeah, I would just say something like that, you know. It is usually impossible or very difficult to travel in a perfectly straight line between 2 points. And you know what? To be honest, I'm quite bad at these contextual answers because I often get the wording wrong, or I often miss, you know, a key piece of information. So there's probably something specific they're looking for here, which we're going to be able to pick up on when we have a look at the mark scheme. And I need to be careful when I do this because I don't want to look at answers that I haven't done already. I really dislike, if I'm looking at a paper for the first time, to see any answers that I haven't done yet. I feel like it ruins it. Okay, this is question 2. The answer looks like 16 on 9. That looks fine. And the factorization was fine. They don't give any specific reasoning as to whether to include this solution here or not. I guess they just want us to ignore it because it's a square equal to a negative, and in AS level mathematics we don't learn about that topic yet. Okay, so that was question 2. Then question 3 was 9.8. And the contextual question, the road is not likely to be straight. I think that's good enough. There are likely to be objects in the way. Fine. Okay, on to the next one. Let's zoom in a bit now that we can. So what sort of topics are you covering in your first year of O-levels? Anything interesting? Anything you're enjoying learning about? Oh, curve sketching. Reciprocal graphs. They look like this roughly. They look like this roughly. And this is a positive. So yeah, it's in the first and the third quadrants, right? I just need to close my blinds because the sun is shining in my eyes. Yeah, okay, so let's get started on this reciprocal graph. I haven't looked at graph sketching for a while, so I'm a bit worried about this question. But hopefully it will be alright. Graphs, geometry, trig, and algebra. Cool. Sounds like you're pretty comfortable so far. Or that's what it sounds like from your message. Okay. So it says sketch the curve with equation y equals k on x. So we don't have any specific values, so we're just going to go ahead and I think that, no, get the rough shape. This is an AS level paper. So the first year after GCSEs. And this topic, curve sketching, is one of the first new things you learn about. Okay, let me do this a bit better. No problem. This is really hard on this notepad. Okay, I'm gonna have to do it like this. Jeez. I don't know why it's so hard on this tablet that I have. That is awful. Slide rule. A slide rule. I have no idea, to be honest. I mean, I feel like if you know how to use a slide rule, that's just impressive enough that you deserve the right to take it with you. I don't even think I know how to use a slide rule. I remember once I wanted to learn and I looked at it briefly and I was like, I can't remember if when I looked how it worked, whether I thought, oh, that's pretty simple, or, oh, that's too complicated for me to bother with. It was one of those two things, if that makes sense. But I didn't actually bother to kind of really sit down, and I don't have a slide rule, so I didn't really ever practice with one. Good question. You should ask your an exam officer person who they know all the rules about these things. But all A-level papers, by the way, are, you're allowed to take a calculator in with you. It's just the GCSEs that you would be thinking about. Okay, so ignore my rough, I have to sketch it like this to get that curve that I'm going for, but just ignore, if it was pen on paper, I could do it properly. Actually, let's give it another go. Let's give it another go. So it looks nice. Let's give this another go. Why does that happen? Fast. Nope. I don't know why it's doing that, going all wonky. So when I do it over here, oh, it's doing it there too. Let's try again. Oh. It's a spot on my tablet maybe that's going a bit funny. Oh, whatever. I don't know what's going on with my pen. Something wrong with it. Why is this being so weird? it's not doing what I want it to do. Okay, that's a bit better. That's good enough. I'm sick of trying. Yeah, I'm trying to rotate the tablet, and when I do it, it goes all weird. Like, look, I don't know. I'm trying to draw a straight line down, and it goes like, yeah, it's not doing what I want it to do. It's weird. But yeah. Okay, so let's say we're doing 1 over x. Then we have a point at 1, 1, right? When x equals 1, when x equals 1, y equals 1. And when x equals negative 1, y equals negative 1. Okay, so what about if we have 16 on x? 16 on x, what happens then? Well, when x is 1, y is going to be 16. So this is going to look a bit different, right? So this is a transformation when we change that number k in the numerator. Solve the inequality. Well, we could. I didn't even think about that, to be honest, because they ask us to sketch the graph, so I'm thinking I want to use the graph. But okay, let's have a look at if we just solve the inequality. So we multiply by x, we get 16 less than or equal to 2x, and then x greater than or equal to 8. But I guess the point is x could also be negative. So then we would get x less than what would happen if you know what, I just want to use the graph since we've got it here. Well, actually I wanted to finish my thought on this transformation. What happens when we change this numerator first? I kind of just wanted to remember this point about graph transformations. So when that numerator changes, so the generic graph is y equals k on x, and then when k, for example, increases from 1 to 16, what happens? So, oh, okay, so hang on. What about when, okay, so let's look at this graph y equals 16 on x. Yeah. So when x is 1, y will be 16. So it would be like, what about when y is 1? X would be 16. So what would be this point here? when they're equal. 2? No. Well, 2, no, 4, right? 4. Why was I blanking on that? 4. What's going on? I'm trying to remember graph transformations of the reciprocal function. Just some basic stuff that's just, you know, just trying to remember the fundamentals, I guess, from first principles. So I'm just looking at this transformation. If we've got y equals 1 over x, and then y equals 16 over x, what's the transformation? And it's a translation of the graph, I think. Although this point goes from 1, 1 to 4, 4. Oh, all good things must come to an end. Summer is over. Sadly. It's autumn. The sunny days are behind us. It's a sad day. Graph transformations. Graph transformations. I'm just looking something up because I can't remember what the point is. Even though I made a video on this before. Oh, right. Oh, it's about the asymptotes, right? Reciprocal graph transformations. I don't know. Not finding anything. So let's use our brains. What I'm trying to do, so in AS level mathematics you learn about graph sketching, and one of the graphs you need to learn to sketch is this reciprocal graph, y equals k over x, which looks like this, has this general form, has these two curves like this in the first and the third quadrants. So this is your x and y axis, and this is the general form of the graph k on x, which is called the reciprocal graph. Reciprocal graph. And I'm just trying to remember what transformation happens when you increase this numerator here, for example, this numerator from 1 to 16. What is happening to that graph if we sketch y equals 1 over x and then y equals 16 over x? what transformation is occurring there. Hopefully that made sense. Closer to the line. Which line? You're probably right. I just don't know which line you mean. So for example, the x and y axis, doesn't it get further away? Or did I get this wrong? So for example, y equals 1 on x, you have a point at 1, 1. So I believe it would be here. 1 on x would be in between the x and y axis. Oh, does it? Am I getting that wrong? Let's check. Okay. So if you go from 16 to 1, it gets closer to the x and y axis. On the decreasing coefficient, right? Yeah. Yep. Yeah, I guess that's good enough. Let's go with that. So as the coefficient increases, it translates further or stretches further from the x and y axis. Okay, so now we're looking to solve this inequality here. So this reciprocal graph needs to be less than or equal to 2. So the line y equals 2 would be like here. So I guess, oh, the asymptotes. Well, this still has an 16 on x still has an asymptote at x, right? Yeah, okay, so when y is 2, x is 8. Asymptotes. Asymptote. Do you know what an asymptote is? An asymptote is a line that the graph approaches but never actually touches. So this reciprocal graph for this one, k over x, the y-axis is an asymptote because the graph approaches the y-axis but never actually touches it. And it will get closer and closer to, yeah, just like limits. So it'll get closer and closer to the y-axis as x decreases. It will get, into infinity, it will get continually closer, but it will never actually touch the y-axis. That is what we call an asymptote. Asymptote. Like that. So we will have, for this graph less than or equal to 2, x is greater than 8, but also this whole section will have to be included as well. So it's also x less than 0. Right? So it is, so for the solution to this inequality, we will have just using the graph, x greater than or equal to 8, or yeah, equal to, because it's 16 on x less than or equal to 2, and we'll have x less than 0. right, for this whole section of the graph down here. And it's only less than because x can never actually equal 0 on this graph. And this solution, I guess you can't find algebraically, because if x is 0, this has no solutions. The tangent function does have asymptotes. So the tangent function is that funny one. Do a quick sketch down here. The tangent function is like, oh, that's terrible. Something like this. And it has asymptotes at 90 degrees and so on. 90 degrees, 270, 270 plus 180, 450, right? And so on. Yeah, exactly. Okay, so let's check that one. X greater than or equal to 8 and x less than 0. So I'm having a look at the mark scheme. Yes, we are correct. These are the two solutions for part B. And I think you need the graph for that. At least I don't see how you solve this algebraically to get x less than 0. Or I'm not sure. Hmm. 16. Oh, well, I guess, yeah, you do, right? Because you just say if x is negative, this is less than 2. Yeah, so that does give you. So you can just find that algebraically. So, yeah, you don't really need the graph. If x is negative, it's obviously less than 2. And if x is greater than or equal to 8, it's less than or equal to 2. All right. On to question 5. It looks like some kind of integration question. We're going to have to find an area. The finite region R shown shaded in figure 2 is bounded by the curve with equation y equals 4x squared plus 3, the y-axis, and the line with equation y equals 23. Show that the exact area of R is k root 5, where k is a rational constant to be found. 5 marks? That's a bit scary. Why is it 5 marks? Does that mean it's going to be hard? I don't want to do a hard question. Do we have to use our brains, guys? Do we have to use our brains? Why do we need this plus 3? Is my initial thought. Because if I just ignore that plus 3, then I can just do then I can just do this problem. Will it have the same area? It should. Or will it? Because all I've done is shifted it down 3 units, so it should have exactly the same area. It looks a bit deceiving how I've sketched it, but I think that's just an issue with my drawing. Turn the equation around? Do I need to? Oh, right, because we usually do under. I see what you mean, right, yeah. Yeah. There's a couple ways you can do it. You can find this area. And subtract it from the rectangle. Your method sounds more interesting, but it also sounds harder to me. Because I have to rotate the thing. So, well, actually, what would it be like? So, yeah, we could do it this way. Find the area under the curve, which you should know how to do from learning about integration. This is one of the first things you learn how to do, find an area under a curve. And then subtract it from this rectangle. And you should get that shaded area. Or you can look at this problem not as y equals 4x plus 3, but as x, what would it be? Oh, you need to find the inverse, right? Don't you? So if y equals 4x squared plus 3, then x this is more why take 3 on 4? But then you have a square root. Don't you need the inverse? That's what this would be, right? This would be y equals the square root of x take 3 on 4. Then the integral becomes much harder. And I don't want to do this integral. But no, I like your thinking. I like straight away when you saw the question, you said, "Oh, I want to do it this way," and I love that, and I like exploring it. But I don't want to take the I mean, I like going with your suggestions because like it's really fun to just go off on a tangent, but also the integral of a square root is hard, man. And this is just so much nicer. So we're going to go with the first method. And maybe we'll look at this. So I'm looking at this now and I kind of want to do it. So, so it's like, it's just, so it's to the power of a half. It's actually not that bad, is it? Because you could just write it as, a half x take 3 to the half. Then you need to use the chain rule, which is actually not something we do in AS level mathematics. So, okay, alright. I'm sorry, we're going to have to go with method A. So, we're going to find the red area. Oh, Pratham, there's another way to do it. Yeah, but don't you need, because you have this, because you have this function to a power, you need the chain rule. Have you learnt? Right, don't you? Am I going mad? Oh, right. Oh, if we don't have the 3, of course. Yeah. Okay. Nice. Okay. Yeah. So, as I said at the very start, we can ignore that plus 3, right? So it's just y equals 4x squared, and then we're going to have x equals plus or minus. Yeah, but we don't care about the negative because we're just looking at above the x-axis. So this is y equals a half root x. And actually we can draw it like this. Like so. So that's actually the function we're looking at. And then we can look at that area. Oh, that's nice. Cool. Alright, let's do it this way. It's more fun. So, let's say we can look at the equivalent area under y equals a half root x. This would be 20. And then we need to integrate. where am I from? Well, so this exam paper I'm currently looking at is from the UK. I'm currently not living in the UK. I'm living in Finland. I was in the UK teaching when I started my YouTube channel, and until and for a while I was making videos, but I'm not there teaching anymore. Why is it half x? Is it not a half x because we took the square root? So this process here was me finding the inverse function, which is what this is. So I think that, so to find the inverse, we take the square root and we divide it by 4, took the square root, so we got that half. I think. Hopefully that makes sense. So now we're taking this integral, and we want it from 0 to 20. So we say the integral of y. I actually haven't looked at integrals for a while, but hopefully this is fine. So this is, I mean, this one's pretty simple. We just reverse. We think about what would be the, how would we get this if we differentiated another function? What would we have to differentiate to get this? So we reverse the power rule that we use in differentiation. That makes sense? Awesome. I'm glad, Daniel. So remember, when we differentiate, we subtract 1 from the power and we divide. Right, so for example, if we have x squared, the derivative of x squared is 2x. So we take 1 from the power and multiply the coefficient by the power. When we're reversing this, we add 1 to the power and then divide by that power. So this becomes 3 on 2 multiplied by 2 on 3. So half plus 1 is 3 on 2, then dividing by 3 on 2 is the same as multiplying by 2 on 3. And because this is a definite integral, we don't have to worry about the plus constant. Remember, when you're doing that integration, if it's an indefinite integral, you have to plus the c on the end. But we're not worrying about that. Okay, so this is from 0 to 20, and this 2 on 3 multiplied by half simplifies to a third. So we get the following. And now, well, if we substitute 0 in, that would just be 0. So all we have to do to find this area now is to plug in 20. So this is going to equal a third multiplied by 20 to the power of 3 on 2. 3 on 2. And we're getting root 5 in the answer, though. Oh yeah. Okay. So we need to simplify this in such a way that we have a rational constant multiplied by root 5. So there is a root 5 in 20, which is promising. So let's write this as a third times But what about the cube? What about the power of 3? Oh, right. Yeah, okay. So let's write this as, I'm just going to do it this way. So then this is 2 root 5 cubed, which is then 8. Yes, I know. This is a bit messy, but so root 5 times itself 3 times is 5 root 5. And then we have 8 times 5, 40 on 3 root 5. Okay. The 8 should be inside the root. Huh? So what I did here was the square root of 20 equals the square root of 4 times the square root of 5 using surge rules, and which is 2 root 5. And all of this is to the power of 3. So that was this step here. And then cubing 2 gives us 8. So I think there's no root there. But in any case, let's check the solution. So the rational constant to be found is hopefully 40 on 3. Yes, it is 40 on 3. By the way, I should just pull this up when it's just a bit hard because my mouse isn't working too well. This is what I'm looking at, the mark scheme, and I'm not going any further because I don't want to look at the solutions to the questions I haven't done yet. But yeah, well done, guys. I feel like we really worked through that together. Group effort. I like it. And for those wondering, no, speed is not my goal here. I'm not attempting to do this in any specific time limit. Sometimes I do that if I'm feeling, well prepared. But today is not the case where I'm going, okay, I need to do this in 2 hours. That's not happening today. Although that is a good method to prepare yourself for exams, is to give yourself a time limit, but I'm not bothering with that today. Okie doke. Question 6. The circle C has equation x squared plus y squared takes 6x plus 10y plus k equals 0, where k is a constant. Find the coordinates of the center of C. K is a constant. Okay, so that's just the radius. So we don't need k for the center. So So the general form of a circle is x take, I usually write a, but sometimes you see h and k. Doesn't really matter. This is a general form of a circle where a and b is the center. Yeah, you can do that. Root k on one side. So if we can get it in this form, we can just easily read off the center. So let's write the whole thing out, and let's write it as equal to negative k. So I'm guessing k is a negative, otherwise it wouldn't make much sense. No, it's not going to get complex. It's just that k is a negative number, negative constant. So then we can use completing the square, and or I guess k does not have to be, because we're going to have these positives to add to it. So completing the square to get it in this form, we will have y plus 5 all squared take 25 equals negative k. And then if you want to neaten it up further, you can write it as this, where all the constants are on one side. So 25 plus 9, 34. 34 take k. Okay, so then you've got your center. So the center is center of C at 3, negative 5. If you want to know more about circles, they are some of the first videos in my A-level revision playlist. So go into my channel, go to playlists, see the A-level revision, and it starts off with a whole bunch of videos on circles, looking at the center, looking at tangents. Everything you need to know about circles is there. Part B says, given that C does not cut or touch the x-axis, find the range of possible values for k. Does not cut or touch the x-axis. Okay, so I feel like I want to sketch this. So what would it look like? What would it look like? The center is at 3, negative 5. So down here somewhere. Oops. And the circle does not cut or touch the x-axis, so we have a limit of the size of the radius. Okay, something like that. Well, obviously 34 take k, remember this is the radius squared, that can't be greater than 5. Or to say that another way, the square root of 34 take k must be less than, strictly less than 5. So I guess this is the inequality we need to solve. So We can square both sides. Yes, we can. Shouldn't be a problem with that. Because this has to be positive. And then k is greater than this difference, 9. K greater than 9. So let's say 10. This will be 24. Root 24 is less than 5. Let's say k was let's say k was 25. There will be 9, which is 3, which is less than 5. So this makes sense to me. Let's check. Can someone spot my mistake? Not greater than 9. Oh yeah, greater than 9, yes. Sorry, that's fine. This is fine. It is greater than 9, but there's some detail that I missed. Note so x. So we're not looking for x. We're looking for the radius of the circle. It doesn't. We're not bothered with any values of x. We're looking for r, the radius. So there's a detail I missed. So I would not have got 4 marks for this question, sadly. Can anyone tell me what I missed? K greater than 9, and what must k be less than? What must k be less than? Not 25. It can be greater than 25. It could be 26 and you'd still have a circle. K must be less than. Radius has to have a length. A radius can't be 0. So if k was 35 or 34, we wouldn't have a circle. So k has to be less than 34. Okay, so if k was, for example, 34, 34 take 34 is 0, and then the radius would be 0, which is not a possible value for the radius of a circle. In other words, you don't have a circle. So I missed that. I forgot that detail. Hopefully you learned from my mistake. K is between 9 and 34. Oh dear. First mistake of the paper. But maybe we won't make another one. Not equal to. It can't equal 34 because then it's 0. It's not equal to. It must strictly be less than and greater than. Does that make sense? Oh, look at all these words. Ah, reading. This is a mathematics exam, not an English exam. What is going on? I'm going to take a quick break. I need to feed my dog. So I will be back in about 5 minutes. If you're in the chat, you can have a go at this question on the screen. I hope you're all still here when I get back. It's really nice to have your company. See you in a minute. K would be greater than negative 34. Huh? What? Greater than negative 34. So let's say K, so that means K could equal, for example, negative 30. That would not be less than 5. This would be the square root of 64, which is 8. So, not greater than negative 34. Question 7. The distance a particular car can travel in a journey, starting with a full tank of fuel, was investigated. Wow. Amazing. Fuel? What's fuel? Doesn't everyone drive electric cars these days? Tank of fuel? What's a tank of fuel? Tank of fuel. You mean a full battery? $40 liters remain after travel 80 kilometers. Okay. 25 remained after it had traveled 200 kilometers. So we have a linear model with V being the volume remaining in the car's fuel tank and D being the distance the car has traveled. Find an equation linking V with D. So linear model meaning we don't have to, it's not a exponential. We don't have to square anything. There's not going to be any exponents. It should be a nice straight line. Meaning the distance you drive is directly proportional to how much fuel you use. Now, in real life, actually, it's a little bit more complicated because you have things like acceleration. So in reality, there would be more complicated models for this. But for this question, we're simplifying it quite a bit. So remember, the general form of the straight line is y equals mx plus c. C being the starting value, or the value when x is 0. So what is x? So V is y. V equals volume of the fuel. D is the independent variable, so it's going to be something D plus something. What can we call this? It doesn't say what the amount of a full tank is. Oh, so we don't need, so we won't know this plus c yet. We won't know this plus c yet. But what does the m represent? That's the gradient. So we have 2 points essentially on a straight line, and we can find the gradient between those. So that's what we're looking for. This question is essentially saying find the gradient. Oh, and actually we could find the c, right? We can find the y-intercept. We will be able to find that. Yeah. So I'm going to do this. Yeah, I'm going to do this in the traditional way. So we have 2 points. So for part A, I'm going to say we have 2 points uh, 40, 80 and 25, 200. And then you should know how to find the gradient of a line given 2 points on that line. So it's y1 or y2 take y1 over x2 take x1. So in other words, you subtract the y coordinates and you subtract the x coordinates, and that's like the rides over the run. So 200 take 80 over 25 take 40. And it will be a negative, right? Because it's decreasing as... wait, why is it a negative gradient? So as the distance increases... Oh yeah, the volume in the volume remaining in the tank decreases. Yeah, that's why it's a negative gradient. So it's 120 over negative 15 which is 20 over 3. Why is it 20 over 3? I don't like that number. No, it's not 20 over 3. It's math. It's math. That's what it is. It's 24 over 3, which is 8. Come, what? You think, what? What? You think I'm a maths teacher or something? Give me a break. Come on. I never said I was good at maths. I never said that. So, that was the coefficient of D. And then we can find the y-intercept plus c. Yeah, there is easier ways to do this. This is a very to be honest, this is the way I learned how to do it in high school, and it's the way I've always done it. But you can use the point gradient form of the straight line equation, which is what I think Pratham you were doing, which I think is a bit faster. But yeah, there's just a couple ways. It's just the algebra you can do slightly differently. So the point gradient form of a straight line is how does that look? I've forgotten. It's y take y1 yeah, it's y take y1 equals x take x1. Oh yeah, I think, is that right? Is that how it looks? No. Do not write. Oh no, I've written in this area. Good point. Yeah, that would probably lose me marks. Point. Yeah, that's right. Yeah. So that's this is what's called the point gradient form. Oh, that's one of the names for it. And it's a bit quicker to use this equation if you're looking for all the information we are at the moment. So for example, you can plug in y1 here. Well, I guess you still need to find m. Yeah, and then you plug in any point and you get the equation. So actually, let's do it. Yeah, let's do it that way. So we have m now, which is -8. And we're going to use the point gradient form. So then you write the equation with any point. Either of these points is fine. Let's use the smaller one because the numbers are smaller. So y take 80 equals x take 40 multiplied by the gradient, which is -8. This is going to give us the equation of the line. And actually we should use the correct variables. So y is actually v. V take 80 equals x is d. D take 40 multiplied by -8. So expand those brackets. This is -8d plus 320. Huh? Okay. And then add the 80 to the other side, plus 400. The equation you have is the amount remaining in the tank. Yes, that's what we were looking for. The fuel remaining in the car's fuel tank. Okay, so apparently the tank has a capacity of 400 liters. Does that make sense? That seems quite a lot. There can't be 400. What did I do wrong here? Is this fine? Well, let's do it the other way. So we have v equals negative 8d plus c. Let's plug in a point. 80 would be the same. $400? Gradient should be positive? $400, but if the tank has a capacity of 400 and 40 liters remain after it's traveled 80 kilometers, that's crazy. Uh, 40. Wait, am I not reading this correctly? I think the negative gradient is fine. Okay, let me draw a sketch. There's something that I'm missing. There's something I'm not understanding. I have these 2 points. 40, let's say 40, 80, say is about here. 25, what do these points mean again? 25 leaves remain after the car has traveled. Oh, have I got these around the wrong way? Oh. Why didn't anybody tell me? Idiota. Stupido. D, distance traveled, is our independent variable, is x. V is the dependent variable, is the y. Had my coordinates around the wrong way. Sorry guys. We are smart. We are not. We're just trying. We're trying to get our brains working again. That's all. That's all. That's all. Okay, so I'm getting a gradient now of negative 1/8. Is that okay? Is everyone still with me? So y1, let's do 80. No, I almost did it again. 40, 80. This is plus 10. Wait, that's... Oh, but we add the 50. Okay. Now this is making sense. Now this is making sense. Pratham, did you tell me? Maybe you did. Maybe you told me. I don't know if you did. Alright. Anyways, we got there. We all got there in the end. We didn't panic. We thought it through. And we persevered. That's what it's all about. We kept trying until we found the mistake. That's what it's about, guys. It's not about being right the first time. It's not about being the fastest. It's about thinking, using your own brain and thinking for yourself. Okay? Using your own, being present in your own mind and trusting that you can do what you set your mind to. Okay, the graph would look, so 80-40. 80-40 would be about here. Then 225 would be somewhere out here. Okay, that's making more sense now. So the full tank is 50 liters. Now it's all making sense. Alright. Only took us 4 minutes. It's fine. Given that, on a particular journey, the fuel tank of the car was initially full, the car continued until it ran out of fuel. Find, according to the model, the initial volume of fuel that was in the fuel tank of the car. Wait! Wait! You're telling me this now? Huh? These examiners are having a joke. Well, I've already solved it. The distance that the car travelled on this journey. Right. So that's going to be the x. This is the y-intercept. This is the x-intercept, right? The distance, this would be, in other words, the distance, the distance that it travels is until the fuel gets to 0, until the fuel reaches 0. So we have the y-intercept, so BI we have already. 50 liters. So what they were actually asking for in A was just the gradient. They weren't actually looking for the whole equation. Or maybe they were. We'll check the mark scheme in a minute. We'll see what they meant. Now we want the x-intercept. The x-intercept is when y equals 0. So we have our model. When, we can say when v equals 0, we have negative 8th d plus 50 equals 0. So d equals 50 times 8, 400. Okay. Alright, that was the number we were getting before for the size of the tank, but that's actually how far they traveled on one full tank. It's not very efficient, to be honest. Most cars are much more efficient than that. Get up to, you can get up to 600 or 700 kilometers with an economic car with 50 liters of fuel. Okay. Part C. In fact, the car traveled 320 kilometers. Evaluate the model in light of this information. Well, the model is more optimistic than reality. The model claims the car can travel 400 kilometers on a full tank, but it can only travel 320 kilometers. The model does not fit the the efficiency of the car. Something like that. Okay, so let's check. Question 7. Okay, that's fine. This was good. Initial volume was 50 liters. And the distance traveled was 400 kilometers. Poor model, yeah. Because, so you need to say here something like 320 is significantly less than 400. So mention this significantly. Alright. Ooh. Muhammad, you have a question? Yeah, exactly. So, well, the thing is that if it was just traffic lights, that doesn't really account for the model being 80 kilometers off what the distance actually achieved. this is enough information to say the model is not accurate enough. Where is T formula? Where is Professor T formula? Not sure. I can message him. I didn't mention to him that I was going live today. I just kind of went live. Well, let's see. I'll message him on Discord and see what he's up to. Alright, let's see if he replies. He's gone for tea, yeah. Alrighty. Question 8. We're flying through this. Snails with wings. Figure 3 shows a sketch of a curve C and a straight line L. Okay, given that C is equation f of x, so it's a quadratic. Okay, C cuts the x-axis at 0 and 6. L cuts the y-axis at 60 and intersects C at the point 1080. That's all there on the graph. Use inequalities to define the region R shown shaded in figure 3. Daniel, I'll show you the mark scheme. So they want you to make this point that it's a poor model. That's the key. You don't actually have to give reasons why. You don't have to give reasons why that it might not fit the data. You just have to say it's a poor model, that's all. Let's have a look at that question again, just tell you the wording. So it says, so notice the wording here. It says evaluate the model. Evaluate the model. It doesn't say, sometimes they'll say give a reason why. This one it's not saying that. It's just saying evaluate the model. So that language they use is often important just to notice the type of answer you should give, right? All you have to say here is it's either a good model or not a good model when they say evaluate the model. Hope that's helpful. Alright, inequality. So we're going to have to find the equation of the line and the equation of the quadratic in order to define this inequality. So let's find the equation of the line first. So we just did that in the previous question. Equation of line, not lime, line. Let's use y take y1 equals x take x1 m. And let's find m. The gradient is rise over run. We have 2 points, 60, 0, 0, 60, and 10, 80. So 80 take 60 over 10 take 0. That's 2. 20 over 10. And then plug in a point into this equation. So y take y1, let's use the point 0, 60. So that would be 60. And then x take x1, 0. X take 0 over 2, multiplied by 2. This is then y equals 2x plus 60. Okay, so that's the equation of the line L. The line L. And now we want the equation of the quadratic. So it has a vertical axis at x equals 3. In other words, it's translated to the right 3. No, this is easier to use the roots, right? We have roots at 0, 6. And we can just say then x equals what is this? Is it this? X times x takes 6 equals 0. That would give us those roots at 0 and 6. Right? So this is x squared take 6x equals 0. That's a 0, not a 6. So now we have the quadratic and we have the line. We can define the inequality. So it's less than the line and greater than the quadratic. So y is less than or equal to 2x plus 60, greater than or equal to x squared take 6x. Mistake. Does anyone want to try to find the mistake? Damn. Damn. So how do we find a quadratic from this sketch? We have the roots, but that's not the complete picture. Why not? So I said the quadratic was x squared take 6x equals 0. Sorry. This is not correct. So, why am I not remembering how to find the equation of a quadratic from its graph? Yeah, the roots are not enough, of course, because you could have multiple quadratics going through the same roots. I'm not sure what you mean, Daniel. So, what did I say? I said x times x takes 6 equals 0. I'm looking for the equation of the quadratic from the graph, and I'm trying to remember the method, the correct method that we used to do that. Which is another thing that I've made a video on, and I've done it in plenty of exams, and I'm just forgetting at this point in time. Maybe it's this. So we know C is 0. Yeah, okay. So we're just left with ax squared plus bx. And no, this is y. Sorry, y. This is just so slow though. It's not the equation. That's incorrect. That's the mistake I made. It is not x squared takes 6x. Okay, let's do it the long way then. Let's do it the long way because I can't seem to remember. Yes, the coefficient of x squared is not 1. Why is it not 1, Daniel? Actually, I should leave that there because this was my initial answer, which was not right. Okay, so the way I'm going to do this is we say we want to look for a quadratic that has a general form like so. Now we have the points 0, 0, 6, 0, and 10, 80. Yeah, so let's see, Muhammad. Let's continue with this. So we have these 3 points. So we can firstly say c equals 0. Right? Because if we substitute 0, 0 for x and y, c is 0. Then we're looking for a and b. Then we're looking for a and b. So let's plug in these values. So we get, for this point here, we get 0 equal to a times 36 plus b times 6. And for this point, we get 80 equal to a times 100 plus b times 10. I was hoping to solve these like simultaneous equations, but now I'm not sure. Oh. So b equals 6a. Okay. Okay, b equals 6a. Let's substitute that into this equation. Plus 60a. So therefore 160a equals 80. which gives us a equals a half. Which gives us b equals 3. Is that right? Maybe. So then we get our quadratic equation, a half x squared plus 3x. Yep. No? Did I do wrong? Oh, negative. I missed this negative here. B equals negative 6a. Right. Yeah, that gives us a completely different answer. A is equal to 2. And B is equal to negative 12. So our quadratic is 2x squared take 12. Ay, ay, ay. Sorry about that. So yeah, this factorizes to x. So you notice when we say the roots are 0, 0, and 6, 0, we can get x take 6 as a possible quadratic. But this is also a possible quadratic. Right? So just using the roots is not enough. You need to use another point to verify. So the correct answer there is y between 2x times x takes 6 and less than 2x plus 60. So the straight line was fine. The quadratic we needed to do properly. Yes, that's right. 2x squared take 12x plus 0. Yep. That's the one. Alright. Next one. Wait, did I skip a question? 9. Oh, I nearly missed this one. Using the law of logarithms, solve the equation 2 log base 5 of 3x take log base 5 of x equals 2. Huh? Logs? Who likes logs? Couple things we can do here. Have to be aware when one of the roots is 0. Yes. It's true. Couple things we can do here. Negative 6b. Yeah, that's right. Because I factorized the 2x out. Oh, you mean here? So I got plugging in this point into this equation gave me 0 equals 36a plus 6b, which that we can then say 36a equals negative 6b. Rearranging this equation here. Yeah, cool. Napier. So we have a couple of log laws we can use. I don't know initially what one we should use. But this is the one I want to try first. Log of a take log of b equals log of a over b. And see what we get. So, I think this coefficient just stays as is, right? Or does it? Well, we could raise it to the power of. So that's, I guess, another log law. A log b equals log of b to the power a. Maybe we have to do that. So let's use these two log laws. Have you learnt about logs yet, guys? So this is going to be log base 5 of 3x take 2 squared over x. Equals 2. And what can we do next? what do we do next? We could raise everything to the power of 5, right? Are we allowed to do that? Think so? Yeah, so this would still be equal. If we have A equals B and then raise them both to the power of powers of 5, then this is still a valid equation. Yeah, so we can do that. So let's say these are powers of 5. 5 to the power of log base 5. 3x take 2 all squared over x equals 5 to the power of 2. So this is another log law. So there's 3 log laws we need here. So how to write this? A to the power of log base A of k equals k. Okay, so 3 log laws we need. So in other words, these parts effectively cancel each other out. 5 to the power of log base 5, they cancel out. So then we're left with 3x take 2 all squared over x equals 25, which we should be able to solve. So let's write it like so. And expand out the brackets and see what we get. Alright, expanding these out, we get 9x squared. Take 12x plus 4 equals 25x. Right. And then 9x squared, 25 take 12, 37. That's not a nice number. Why isn't it a nice number? Can we factorize? Factors of 9. 1, 3, 9. Factors of 4. 1, 2, 4. Oh wow. Maths with KS12. It's already got there. Nice. And also Muhammad. Jumping ahead. 9x take 1. 9 and 1. And 1 and 4. 9 and 1. Huh? Good. Thanks. How are you? How does 9 and 1 and 1 and 4 make 37? Did I do something incorrectly? Nine, 81, 9 and 9 and 1 and 36? What? Oh, yeah. Nine and... $36 and 1. Right. Cool. I didn't even try to do that myself. You were so fast. Way too fast for me. Yeah, so 9 times 4 is 36. Take 1 is 37. Very cool. Oh, but wait. I did that wrong. This should be 4x. Yeah. Wait, no, hang on. Now I'm getting confused. Oh, this is 4. Yeah, that's fine. Yeah. So yeah, this is fine. 9 times 9x squared take 36 take 1 is negative 37 plus 4. Cool. Well done, guys. You were just way too quick for me there. You're really, looks like you're really good at factoring quadratics, which is awesome. Okay, so then we get x equal to 1 over 9 and x equal to 4. And let's go back to the question. Oh, that was what we were looking for solutions to this equation. Do I prefer completing the square or quadratic formula? I don't like the quadratic formula, really. It's just annoying. So if I can use completing the square, then I will do that. But often, you know, you can't always. If the answer is going to be some decimal or something, then, oh, well, I don't know. When it... Yeah. I mean, sometimes it's completing the square is just not practical, so quadratic formula is the easiest way to go. Okay, so what do we get here? 1/9 and 4. So let's see. Ah, another mistake. Keep making. I've lost 3 marks so far. I'm not happy, really. Can anyone tell me the mistake here? you can, did you say you can have a log of a negative number? Do you mean to say you can't? You cannot? The 4 is fine. Yeah, the 4 is fine, actually. So what we need to do at the end of this problem is make sure we check these solutions with the original equation, which is something I made a video on, well, not that recently, but I made a video on this as well, is you need to make sure that the final solutions fit with the original equation. So can you substitute these values of x in for x here? If we substitute 4 in for x, that's fine. We had x equal to positive 4 as a solution. That's fine. This would give us log of 12, log of 10, and log of positive 4. But if we substitute 1 over 9 in, this becomes 1 take 2. Sorry, no, not 1 take 2. 1 on 3 take 2, which is a negative. So the only valid solution here is x equal to 4. X equal to a ninth is not a valid solution. So, another mark down. Oh, you say, can we go faster? But you didn't spot the mistake. So, I don't know if I can trust you, Muhammad. I don't know. Halfway. Question 10. The line L has equation y equals 3 on 5. It's alright. Just joking. It's perpendicular at L and passes through the point 8, 0 as shown in the sketch in figure. Wow, you're in year 11. That's really great that you are trying this stuff. Okay, so we got to show this equation for L2. Oh, I don't know if I'm going to be able to finish this today. I'm going way too slow. Not good. I mean, I've been kind of trying to do things in a way that has been intentionally kind of slowing myself down, like trying to remember things from first principles and that kind of thing. But yeah. Okay, so equation of L2. We have equation of L1. We have the gradient. So the gradient of L2 is going to be the negative reciprocal. So negative 5 on 3. And then we have a point. Do we have a point on that line? Passes through the point 8, 0. Oh, this point B is 8, 0. Yes, we have a point on that line, so we can go ahead and find the equation of that line. So let's say m equals negative 5 on 3, and then we can say y take y1 equals x take x1 times m. Using that 0.80, we have y equals x take 8 times negative 5 on 3. So y equals negative 5 on 3 plus 40 on 3. Which you can write, 24? Why 24? X. Oh, yeah. Wait, no? Why 24? Okay. I'm getting 40 on 3. And if you multiply through by 3, you can write it as such. Ah, right, you thought it was 0.8. I see. Okay, oh, and it was a show that question, so we know we are fine. Next, given that the lines intersect at point C and line L1 crosses the x-axis at point A, find the exact area of the triangle ABC. Give me your answer as a fully simplified fraction. So we're looking for this area. This area. At this point, I guess we can find this point and then this point here. Okay. That will give us C, will give us the height. Okay, so we just need to find where they intersect. And so let's write the equations of the lines down below. So L1 was 3 on 5x plus 6. And L2 was y equals negative 5 on 3x plus 40 on 3. Okay, so let's find where they intersect, so where they're equal. Lines intersect when 3 on 5x plus 6 equals negative 5 on 3x plus 40 on 3. 40 on 3. Okay. Hang on. Hold that thought, Mohammed. Give me a second. What can we do? Let's multiply through by 3. So 9x on 5 plus 18 equals such and such, and then multiply through by 5. I don't know if this is the smartest way to do it, but it's the way I'm going to do it. Yeah, definitely not the fastest way. Oh, whoops. Not 9, 5. Doesn't. Oh, I'm really failing on basic arithmetic today. This was right. This is right. I thought for some reason I got it wrong. Why though? I don't want to use that number. Yuck. Well, I guess all we need is the y value. Huh? I don't like it. It's not nice. Six 30. Ugh. Six. Okay, so that's the height. Then we want the x-intercept of L1 when 3 on 5x plus 6 equals 0. So then 3x plus 30 equals 0. So x equals -10. Okay, so remember this number? Going to go back up to the graph now. Actually, remember both of these numbers. Going to go back up to the graph and show you where they are on the graph. Oh, Mohammed, thank you so much. It's nice of you to be here. This is -10, this is 8, and this height here was 7 5/7. So the base of this triangle is 18, and the height is this ugly number. What was that as an improper fraction? That was 47 on... this was meant to be 6. That's nicer actually, because we can multiply that by 18 a bit easier. So the area, let's just write it up here, is 47 on 6 multiplied by 18, which is 47 times 3. 47 times 3, which is 141. And there's no units given, so it's just units. Oh no, it's a fraction. Oh man. Divided by 2. Divided by 2. Never forget the divided by 2. Jeez. 141 on 2. Let's check. Huh? It's wrong. Somehow. Man. Another mistake. It's not 8.25. Or I'm not sure which should be 8.25. You mean the area or something else? Why? Oh, the for C you mean? I don't think. So there's the height. The height is not 8.25. It's 135 over 17 apparently. So it's just annoying arithmetic errors, I think. Unless the mark scheme's wrong. The mark scheme can always be wrong, you know. But probably not. Alright, let's see. Are these equations correct? Yeah. 3 on 5x plus 6. Yep. So the error is in this algebra somewhere apparently. They intersect when they're equal. That is fine. This should be fine. Hey Pratham, welcome. You'll be sad to hear I made another error. Some arithmetic error somewhere in here. Do you think you can help me find it? Multiplied by 3, 9x plus 9 on 5x plus 18 equals negative 5x plus 40. Multiplied by 5, 9x plus 90, negative 25x plus 200. This is fine. 9. Oh, wait. Wow. 9 plus 25. Sheesh. Man. Man. $34x equals 110. So x equals 110 on 34, 55 on 17. And then y equals 3 on 5 times 55 on 17 plus 6 equals 11 on 33 on 17 plus 6 equals whatever the heck this is. 6 times, my brain's tired. 6 times 17, by the way, you can always use a calculator in all A-level exams, so not doing anything wrong using a calculator. 102 plus 33, 135 on 17. So that is the correct height. 135 on 17, that was the mistake. So if we go back to the diagram, this should not be 47 on 6, this should be 135 on 17. Then for our working out here, we get 135 on 17 multiplied by 18 multiplied by a half, which doesn't simplify at all. So 135 times 18 divided by 34 gives us 71 point. Let's round it off. 71.47 approximately, which is the correct answer. As a fraction, it is 1,215 on 17. There we go. Okay, so small arithmetic error there, costing me another probably 2 marks at least. So far I've lost 5 marks in total by my count. Not good. Not happy. And I think that's going to be about it today. I need to take Ollie for a walk, and I could leave the stream going and just come back, but it would be just nothing happening for about 30 minutes, and I think, I might as well just end it here. So, thank you for joining me today. I hope you learned something, and I have very much enjoyed your company. So, I'm looking forward to making more videos and trying to be more consistent on YouTube. Going into the next school year. When is the next live stream? I'm not sure. What would you like to see from a live stream? What do you find helpful with a live stream? Do you like going through questions, exam questions? Do you like like going through viewers' questions? Next year, not next year. It'll be sooner than next year. Exam questions. Well, maybe tomorrow we can just finish this paper off. I don't know. We'll see. And viewer questions. Yeah, cool. Cool. And remember, if you have any questions, you can always put them in the Discord as well. There's always people in there, very helpful people as well. Alright, thanks a lot, and I'll see you next time. Look out for, if you subscribe, you can see I'll often schedule live streams, so you'll see that one is scheduled for, particular day, and you can see it coming up. So, alrighty, thank you so much, guys. See you next time. Bye.